Okay, great. Good morning once more. Good afternoon. Good evening, fellows, depending on where you're joining us from. My name is Lavenda Ochieng. I am a research assistant at ARIN, Africa Research and Impact Network, and I warmly welcome you all to today's review session. This is a very interesting topic, looking at the evolution of soil moisture variability in relation to land use and land cover changes using remote sensing and GIS techniques. So this study was done in Southwest Ethiopia. And we all know that soil moisture dynamics are critical for agriculture, the water resource, and even climate resilience. So it influences the crop yield, the water availability, and even ecosystem health. So this study, we aim to assess the soil moisture variability in relation to land use. They have said it as the title. And we'll try to unpack the urgent need for sustainable land management practices. So in addition, we'll also assess why these practices are critical to combat environmental degradation, improve soil moisture retention, and even ecosystem resilience. So this will, the ultimate goal of this review is to ensure that the solutions that we have are sustainable and they are climate resilient. They build a climate resilient future. So having mentioned all that, I'll briefly introduce our speaker, who is Mr. Zenebe Reta Roba. I've pronounced it well. He's a lecturer and the Dean of Natural Resource and Agricultural Economic at Mattu University. This is found in Ethiopia. So, Mr. Roba, I'll welcome you to take us through the presentation. In case you need some help in sharing the screen, I'll be available. Otherwise, over to you.
All right. Thank you very much for just giving me this chance to present, my our findings on African Impact Research and Impact Network. So let me just try to share the a slide first.
Okay, go ahead.
Yeah. Wait a minute. It's visible.
Yes, just put it in the presentation mode.
All right.
And just a
So
reminder,
is it?
you have 40 minutes.
Yeah. Okay, first of all, I wanted to say thanks for Africa Research and the Impact Network for just facilitating these types of presentation and in order to share my experience and my just presenting my our findings with the teams. So as you see from the titles, it says evaluation of soil moisture variability in relation to the land cover change in using GIS and remote sensing technique, the case of Southwest Ethiopia. But before that, I wanted to say something about my experience and my educational background within 1 minute. So I do have a general forestry background from Urbana University, Ethiopia, and I have MSc in GIS and remote sensing or just special technology from Jimma University, and I do have a numbers of experience. Just I am serving as a lecturer for more than 7 years in Mattu University, and I am currently just serving as Dean College of Natural Resource and Agricultural Economics at Mattu University, as mentioned earlier. And I do have a global experience in the research. Like I'm just acted as academic editor on PLOS ONE journal from January 2024 to 2025, and I have also reviewed for more than eight Scopus index journals, for starting from 2022 to present. I'm also currently board member of Open Global Publishing from November to present, and I do have more than one series publication with my teams. So having said this, let me directly proceed to, so it have the outlines as like findings and the conclusions. So can you hear me?
Yes, we can hear you, but the slides are not
Yeah.
moving.
So let me just start from the introductions. As usual, land use land cover change is globally influences soil moisture dynamics
Sorry,
and
Robert.
shaping water
Sorry.
availability and ecosystem.
Sorry for
Yes.
interrupting. The slides are not moving and they're also not in presentation mode. I don't know if it's from my side, but yeah, at the
Okay, I
bottom.
already shared it.
Please reshare it again. Maybe
Okay.
just
Let me
one.
stop it and reshare it again.
Thank you.
All right. Okay. What about now? Hello?
Can see the slides, but is not. Can you maybe
It's
you see that
in,
exactly? Click there.
yeah, what about now?
Not yet. Can I help from this side, please?
Come again?
Let me help you share the slides.
Yeah, okay. All right. So just put it on the introductions. But it's not fully visible, dears. Hello?
I think it's visible for
Can I?
me.
Can
I
I?
think
Can
now
I?
it's okay.
Sorry.
It's not fully visible, so
Edna, can you see the screen?
yeah, it's actually visible. So how can you just change the slides?
Well,
Lavender, it's not fully visible. Yeah, but now it's on presentation mode.
Let me reshare it. Can I reshare it again?
okay, go ahead. Sorry.
Okay.
Okay.
Hello?
Hello.
Is it visible?
I think let's just proceed. Let's work with that. Go ahead.
Yes. Is it visible?
Yes, go ahead.
All right. As usual, land-use land cover changes globally influence soil moisture dynamics or changes, and it can affect the availability of water and ecosystem resilience, and it may affect the ecosystem balance by itself. So, understanding this effect is very essential and important, specifically in our country, in the steady areas. So, in Africa, the most of land-use land cover change is particularly pronounced due to the factors like rapid population growth and increasing demand for agricultural lands. This has been lead to widespread deforestation and agricultural expansion. So with the expenses of forests and other important vegetation, so the soil moisture variability can be pronounced. So that over recent decades, Ethiopia has experienced accelerated land transformations that have disrupted hydrological process such as infiltration, evaporation, and soil retention. So the southwestern highlands of Ethiopia, including the state areas, are particularly momentous due to their rich ecological diversity, and it impacts land changes on the landscapes, as stated by the scholars Gabriel Hiotz. So, despite the establishments of Green Legacy Initiative, as we all know that currently since 21 nights, the Green Legacy Initiative has been launched in our country, but still in some parts of the areas, still there is deforestation, and it is not balanced. It may be due to management activities. So that at the national level, deforestation in the state area remains unbalanced with that of green legacy, so leading to ongoing environmental degradation. So that's why we are interested to conduct these types of studies. So soil moisture in these areas are crucial factor influencing vegetation growth and the groundwater recharges. Hence, the variabilities of the soil moisture in response to land cover change remains, unstated despite its importance specifically for sustainable development. So most of the existing studies or the present studies in Ethiopia and specifically in the state areas have predominantly focused on land cover change alone, without just considering the factors like the indices, specifically NDVI or normalized different vegetation index and this normalized difference moisture indexes. While this study may be enhanced our understanding, but they overlook the direct linkage due to land cover change and with that of the indices that we measure using geospatial techniques. So that the present study specifically aimed to just solve this significant gap by employing a novel methodological framework that combines advanced GIS and remote sensing technique with time series remote sensing data. Specifically, we utilized the 3 indices in order to measure the soil moisture variability, specifically in relation to land use land cover change, like normalized difference moisture index, normalized difference vegetation index, and the SAVI or soil adjusted vegetation index, to provide a detailed understanding and a comprehensive understanding how land use land cover change can affect the soil moisture variability. Therefore, by integrating these indices, the study offers more accurate assessments of interaction between land use land cover transition and moisture dynamics. It may be critical for effective land use planning and climate resilience, as well as sustainable agricultural practice. So the second is materials and the method. We have used a number of methods in order to analyze and providing comprehensive understanding about the soil moisture variability in relation to land cover changes. Specifically, the state area covers 11 districts under the 2 zones in Bunu Badal and Ilobaba zone in the southwestern part of Ethiopia. So that this is the state area map as you see, and again, data type and the data source. We utilized remote sensing data like Landsat thematic mapper and enhancer thematic mapper for 0224 and OLI or operational land imager and tiers for 2024. So we utilized satellite images in order to analyze the changing land use, how the changing land use land cover change can affect the soil moisture variability. And again, this imagery was selected from the dry season, specifically January and February, in order to minimize the noise effect and other impacts that affect the quality of the satellite image, because it needs certain types of qualities in order to provide accurate results. So this is the summary of the data that we utilized, specifically by considering the sensor path around the spatial resolution, years we considered, and the source. We have utilized Landsat 5, which is thematic mapper for 1994, and we have utilized also Landsat 7 enhanced thematic mapper and Landsat 8 operational land imager. Specifically, these Landsats are very important, specifically to study wider areas. Actually, we have used also method of data analysis. So in order to analyze, the satellite images, in order to determine the land use land cover changes, first we process, pre-processing is very important, specifically to remove, the factors like noise, clipping, and the band combinations are very important, specifically followed by clipping and just specific to the boundaries. So these steps are specifically very important to prepare the satellite data for classification and analysis. So subsetting also another important step that we need to consider in order to ensure that the only relevant data are included to identify, the changing environment as that can affect the soil moisture variability is alongside with other factors. And again, so land use land cover change analysis is our very important steps that we need to, we have also considered it. So land use land cover change analysis was conducted using Landsat thematic mappers, as I mentioned in the earliest. In this method, classification were carried out using supervised classification method. Actually, there are supervised and unsupervised classification approach that you need to classify the land use land cover changes in the GIS language. So specifically under that, there is also a number of algorithms are there. Among them, we select a maximum likelihood algorithm. Specifically, the reasons that we identify the maximum likelihood algorithm is due to it is provide high accuracy when the data follows the normal distribution and handles specifically overlapping spectral classes in the well manners. And again, also the Landsat images were classified into 4 major land categories. Specifically, these categories can be referenced by a number of articles or scholars. And we have also utilized the software alongside ArcGIS software. We have also identified as software ERDAS Imagine in order to classify the land use land cover changes from the satellite image. And again, this analysis may support us to identify the changing environment and understand how this changing environment can affect the soil moisture variability. And again, another important step under methodology is accuracy assessment is very important, specifically how our methodologies are accurately classified, the satellite image. So with this, we utilized, confusion matrix. We employed the confusion matrix. Actually, we considered two major accuracy assessment: overall accuracy and the kappa coefficient. These are the standard method that need to identify that support us to how the classified Landsat images with that of specific categories of land cover change accurately classified. So this is, kappa coefficient also evaluated. Overall accuracy is also evaluated with the, assisted in the slide using the formulas. And again, change detection analysis. Actually, change detection analysis are also conducted. Representative of latter period, which is 2024, and in the initial period 1994, how the land cover change can affect this, the soil moisture variable. So identifying and analyzing change detection is also another crucial step that also we followed. Another index is normalized difference vegetation index. This is also very important index to measure the availability and the healthiness of vegetation which is existed in the area by considering certain types of bands. And again, so normalized difference vegetation index is computed by near infrared red minus red and near infrared red plus red. These are the formula that need to determine the normalized difference vegetation index. The other important index is SAVI, which is soil adjusted vegetation index. Is the modifications of actually any device to minimize the soil brightness influence, and specifically in the areas with sparse vegetations. That's why we consider these indices also. This one is also, computed by near infrared minus red and near infrared plus red plus 0.5, which is a constant value, and again times into 1 plus 0.5. This is, the detail value how the constant values can be reclassified. And again, normalized difference moisture index is very important index that need to measure or determine the availability of soil moistures and within that of the brightness. So this is used to essential to help to understand the variation in soil moisture over a time and the space. And again, this steady moisture content across various locations was extracted using normalized difference vegetation index, and that's calculated by near infrared, and the mid infrared also considered with that of band 5 and band 4 for mid infrared and band 5. While for Landsat 8, near infrared is measured by band 5 and mid infrared by band 6. This is the formula as you see from the slide, which is used to determine the soil moisture index. Another important thing is a correlation analysis. Finally, is very important. How do these indexes are correlated with these? The reason behind we consider the correlation analysis is because normalized difference vegetation index is measures vegetation greenness and health. The other one is also detects vegetation water content and the drought stress area. So a correlation analysis between normalized difference vegetation index and the normalized difference moisture index is how shows or indicates how the vegetation health is influenced by moisture availability and blah blah. So that's using zonal statistics by itself. These are those zonal statistics we chose because of certain types of importance. We consider zonal statistics without instead of other statistical method due to the mentioned reasons. Specifically, zonal statistics groups values is a meaningful geographic area, specifically land cover type. So we consider land cover type as a factor to determine or measure or evaluate the soil moisture variability. So that's why we prefer to use zonal statistics method. So here is the result and the discussions. Let me just start from the land cover change result. So the analysis of land cover changes from 1994 to 2024 revealed that a notable transformation in the regional landscapes within the specific implication of environmental management and sustainability. So from 1994 to 2024, cultivated lands are expanded with the expansion of forest lands. So this may expose, may reduces the availability of soil moistures. And again, grassland is sharply declined because of certain factors which is existed in the areas. And again, with the expenses of forest land, grasslands or vegetation, other shrublands, bare lands, and some or open lands are in some extent expanded. And again, agricultural lands are also expanded. So these results are also supported by another scholar, the so-called by McConnell, that report or supported this result also. Here is a table that shows how land cover change can really affect the soil moisture variability. So as you see from the slide, in the initial years, forest lands are around 36.4%, but in the latter years, as the end of the years, in percentage, it just declined to 23.7, whereas cultivated lands are in initial years, which means 1994, it showed that like 42, but in the latter years, it may be increased to 72.2%, which indicates that agricultural lands are actually expanded by without considering ecosystem balance, and that can affect the soil moisture variabilities and leads to the stressing of the areas, and they can be exposed for droughts and other types of things. So these are the potential class that we consider in our analysis. And again, so here is a map that shows how the spatial distributions of the map that shows how the forest lands are declined, and how the cultivated lands are expanded gradually. So as you see in 1994, in some extent there is a dense forest, as you see, that is the highly green areas, and the other one is like 2004 is slightly decreasing, and later years forest lands are also decreasing with expenses of agricultural lands. So agricultural lands are expanding highly without considering agricultural, ecosystem balance. Here is also how the rate of change that shows is actually cultivated lands are positively increased and the forest lands are negatively increased, because it is decreased positively, because once the cultivated lands are expanded, the need for food and other agricultural expansion, so forest lands are declined, and the management activities for forest lands are also gradually declined. And again, so accuracy assessment results. So the accuracy assessment of the land use land classification, the state area produced high results with overall accuracy of 93.4% in 1994 and 94.3% in 2004, and in the last year 91.9%. This shows that the classified land use land coverage changes are highly confirmed, and the kappa coefficient is also 0.89 and 490. This shows actually if the kappa coefficient and accuracy assessments are above 75%, the method that we utilized is accurately confirmed, as we just considered from different literatures and the guidelines. So these findings align even with similar study which is conducted across the countries and all over the world. This is by the proceeding scholars. So analysis of normalized difference vegetation index. This is also another important result that just again from the analysis. So normalized difference vegetation index is a critical metric for specifically evaluating vegetation density and measures the difference between its near infrared and visible light reflectance. Actually, the result of normalized difference vegetation indexes are gradually decreasing from 0.71 to 0.52, which is in 1994, the values are showed as 0.71, but in 2024, it decreased to 0.52. This showed that actually the vegetation of dense forests are declined because of expansions of other factors like agricultural lands and open lands. So this decline can be attributed to because of deforestation and the land use land cover change and environmental stresses. Actually, while the lands there is a weak land management in the state area because of certain types of perception, because the peoples or the local communities are giving a due emphasis for agricultural expansion rather than considering ecosystem balance. And again, so the finding highlight ongoing reduction in vegetation cover in some parts of the areas are in need for conservation and sustainable land management, as the results show. So as the studies have shown that deforestation and the land conversion can be significantly affect vegetation in health and leading to reduced and normalized different vegetation. So as you see from the tables, the values of normalized different vegetation result. So in the mean result, as you see that in 1994, the mean result of normalized different vegetation index is about 0.29, whereas at the last years, which means 2020 years of our study period, 0.13, which is significantly decreased because of expansion of agricultural land and other factors, which means that so the forest lands are very highly decreased in the state area because of weak management activities and the conservation practices. Here is the map that shows the normalized different vegetation index. Actually, the value, as I mentioned in the presentation, so in the first year, the high values of normalized different vegetation index is about 0.71, and the latter is 0.52, which is highly decreased because normalized different vegetation index is an indication of existence of forests, whether it is dense forest or sparse forests. If the values of NDVI is or normalized different vegetation index is decreased, there is, high deforestation in that areas as stated in the studies. Here is also soil adjusted vegetation index. So this is also another measure that you need to just identify, just that we consider as a measure of soil moisture variabilities. So the result shows the soil adjusted vegetation index result provide us, a maximum of a decline can be observed in the areas. Let me see the table here. So as you see from the tables, hello?
Hello.
Are you with me?
Yes.
Yeah. So this is the SAVI value, the SAVI trends in, as you see, the mean SAVI value or soil adjusted vegetation index in the first years or initially in 1994, before 30 years, the values are to 0.29, which is very high, whereas in the 2024, it decreased to 0.14, which means that, highly, there is a decremental trend also that shows, which means that actually, healthy vegetation are decreased, which means the dense forests are decreased with the need for food and other agricultural expansion. It may be for farming and other things. Forest lands are highly lost in the steady areas. So it needs certain types of, management activity in order to balance our ecosystems. Here is also the map that shows the soil adjusted value. So in the 1994, like the high values of soil adjusted values are 0.85, whereas in the last years 0.63, which is highly decreased. This affects the availability of soil moistures and lead by, declining of our environmental productivities, and our ecosystems are not balanced. So in order to balance our ecosystem, we have to balance, the existence of forests and with that of expansion of agricultural productive side by side. The other important index that we considered is the soil moisture index. So then the any normalized difference moisture index values from 1994 reveals a significant variation in soil moisture over the past 3 decades. We consider the 3 decades for this study in order to evaluate its long-term status. So the maximum or the high values of normalized difference moisture index decreased slightly, as you see from the slide, from 0.38 in 1994 to 0.05. The decline is a slight, but it is significant change that affects the variability of moisture with that of brightness. In contrast, the minimum NDVI values are substantially increased, which means the negative values. And again, the increase reflectance rise in the lowest recorded moisture level, which may signal of reduction of moisture variability across landscapes. So that the mean normalized difference vegetation indexes are decreased, that is the mean, from 0.142 to 0.009, which is highly decreased, which showed that this is actually the measure of index that used to measure the soil moisture variabilities and soil moisture contents on the reflectance. So
Mr.
that
Zenebe,
it
please change
decreased
the
from
slide.
0.
The slide is not
Yeah.
visible.
It's not visible now?
Yeah, it is on table 5. Please change the slide.
Table 5. It is on table 5?
Yeah.
What about now?
It's no change.
Okay, what about now?
Now, yeah. Now it is visible. Or map, yeah.
That's
Savvy map.
very important. That's very important. So this is a map that shows the SAVI values. Here is also soil moisture index. That's normalized difference moisture index. That is a measure of soil moisture existence. So as you see from the slide, from our initial study prior to final years of study, which means 1994 to 2024, the values of the normalized difference moisture indexes are highly decreased from 0.38 to 0.58, but that is the maximum value. When we see the mean normalized difference moisture index values are also declined from 0.14 to 0.09, which is highly significant changes that shows highlighting the general reduction in average soil moisture existence in the areas, which means that because of soil moisture existence and forests have direct link. If the forest areas are declined, so the soil moisture in the areas are substantially decreased. So So overall decrease in mean normalized difference vegetation index suggests that a trend towards lower soil moisture level, which could have significant implications specifically for ecosystem function. And again, also other studies support this finding, indicates that changes in land use land cover change have far-reaching, affecting soil moisture and the ecological balance. So it confirms our studies are in line with the other finding, which is conducted by the scholars. So largely, the normalized difference moisture index tends observed in the study underscores the critical need for sustainable land management practice and mitigate diverse effect of soil moisture. So we have to maintain, we have to balance our ecological integrity. We have to balance with that of agricultural land and with that of forests in order to make it our ecosystem balanced and just making it suitable for the residents and to increase the productivity of the land by itself or the environment. So as you see also from the tables, normalized difference moisture index value, let's see the mean values. The mean values are decreased from 0.14 to 0.12, I mean 0.009, which is highly decremental because of variation in land cover change. This is also the map that shows the spatial distributions of the existence of soil moisture. So in the earlier presentation, I said that the high moisture values are decreased from 0.38 to 0.35, which is highly decreased, and that affects the productivity of the environment there, and the ecosystem balances are less. So it may expose to environmental factor and other types of degradation because of expansions of agricultural land with that of expenses of forest lands. So the relationship between land use land cover change and the soil moisture. So the study revealed that, or the study showed that significant decline or decremental in soil moisture across different land use land cover change indicated by normalized difference moisture indexes. This is one of the index that shows how the soil moisture can be varies from year to years. So the bare land dropped from, let me see one by one. The bare land is also one of the potential land use land cover classes that we considered for our studies. So it is dropped from 0.1 to 0 minus 0.3, which is highly decreased, which shows that severe soil moisture loss and the increased land degradation due to reduction vegetation. And the cultivated land normalized, it is actually decreased from 0.3 to 0.11, which is highly significant reduction in soil moistures. The game forest land, also forests retain higher normalized different moisture values. They showed steady decrease from 0.4 to 0.23. So, which is highly decremental, specifically because of deforestation and the climate change affects the regional hydrologies. And the grassland is also declined. So this implies that severe moisture loss in the bare land and cultivated land are highly increased. The degradation risk, and the forest and the grasslands are more resilient, show declining moisture levels. So we have to support, we have to balance, or we have to conserve our forests in order to maintain this moisture variability. And then sustainable land management is specifically critical, and we have to take into consideration some types of depletions of soil moisture content, and we have to balance our ecosystem. So the study areas show that there is high soil moisture variability can be existed. So here is the relationship, as you see, which is shown by the tables, normalized difference moisture index, and with that of maximum, mean, and mean of normalized. So these are the results, which is vary from year to year. So the correlation of normalized difference vegetation index and the normalized difference moisture index. So the analysis showed that highly significant linear relationship between the normalized difference moisture index and the normalized difference vegetation index, which is with R value of 0.98, which is very significant. So this showed that while the normalized difference or the existence of vegetation can be decreased, also the soil moisture also decreased. They are direct relationship with each other. So while we are just conserving a forests, values of normalized difference vegetation indexes are increased. Simultaneously, soil moisture indexes are increased also. So we have to manage, but in the study areas, these values are gradually decreased and decreased with that. So as the NDVI increases, so NDVI normalized difference moisture exists. So we have to make it, we have to consider there is little conservation can be visible as the result shows. So other studies have also demonstrated that robust correlation between vegetation index, like normalized difference vegetation index and the moisture index, also shown. Like for instance, a study by this scholar does found that normalized difference vegetation index and the normalized difference moisture index are closely related, specifically in monitoring vegetation health and soil moisture content, specifically in the semi-arid, with that of serving as a reliable predictor for moisture content, vegetation moisture content. So they are directly related with each other. So we have to manage our forests in order to. Here is also the result that showed that the NDVI can affect the predict change in normalized difference vegetation indexes. So once the values of normalized difference vegetation index increases, also the normalized difference moisture index is also increased simultaneously. So when I came to the conclusions, so the evaluation of soil moisture variability, and specifically in response to that of land use land cover changes, shows a significant environmental trend or changes. So the landscape has underscores notable shifts, with bare land expanding from the 7.8 kilometers square to that of 22.6 kilometers square, so or 0.3%. And the cultivated land also increased from 42 to 72.2%, which is highly significant change with the expense of forest land. But in contrast, forest cover declined from 36.4% to 23.7%, while grassland reduced drastically. And again, so the NDVI values dropped from 0.71 to 0.52, which indicating that there is a decline in vegetation health and cover, while the NDVI or normalized difference moisture index value decreased from 0.1 to 0.009, show that high soil moisture variability, which lead to aridities. So a strong correlation also found with R values of 98% with between normalized difference vegetation index and the normalized difference moisture indexes. This underscores the critical link between vegetation cover and the soil moisture retention or soil moisture availability. Highlight that urgent need for environmental degradation. So we have to manage our forests. We have to consider. We have to balance our ecosystem in order to maintain it is ecosystem to develop ecosystem or climate resilient environment. So we recommend some of I recommend some of the recommendation from the studies. So strengthening green legacy as a national level since 2001. The Green Legacy Initiative is actually launched by our government, but in some part of the areas it is effective and the highly land cover changes are existed. But in the state areas, when we compare it to other sites, there is high decremental because of it may be because of management activity, or it may be because of perception of the local peoples. So enhancing or increasing or strengthening the Green Legacy Initiative is very important. And again, enhance policy enforcement, so specifically to regulate land use and prevent deforestation, as well as it is very important to expand community participation, specifically in forest conservation and sustainable agriculture, by providing certain types of training and perception for the residents. So also it is important to prioritize integrated land management, specifically for soil moisture and vegetation retention. And again, also by recommending this one, future study should consider additional environmental variable that we have not considered that to specifically to understand or to generalize more comprehensive understandings of soil moisture dynamics. So generally, so the study showed that highly the forest land in the areas are highly decreased, as you see by maps and by table and other analysis by graphs that showed that the agricultural lands are highly increased and increased. So we have to. So we recommend at the local people or the administrative have to strengthen the Green Legacy Initiative and increase the management activities of the planted trees which is existing on the areas to increase the forest coverage. Once the forest coverage can be increased, our ecosystems are balanced and even the agricultural product increased. But currently, without our ecosystem, the local residents are, as the result shows, they are giving the priority for agriculture without sustainable land. We consider these issues. So I wanted to say thank you attention. Here is my address form. Very much. Thank you very much for your attention and just your insightful participation. Thank you very much.
Thank you. Thank you so much, Doc, for that insightful presentation and critical highlights on how NDVI and NDMI are correlated. So I think this really brings the aspect of evidence in making a decision, because this is real and you can see the correlation between the two. Even the recommendations are critical as well. And I really thank you so much for that.
Yeah.
So at this point, we're going to the Q&A session, and I can see some people have already put in the chat section the question. So in case you have a question or a comment, kindly just feel free. We'll have like 20 minutes to address any concern, any comment. Yeah, the floor is yours. So I'll start with Peter's. I don't know which Peter is this. Peter, kindly just go ahead. I can see Gogo has responded to it, but maybe if there is a need for further clarification on the same. Peter? Oh, you can speak. Okay. I'll just read it for you, just in case there is. Peter, maybe indicate if you need some further clarification. Yeah. So meanwhile, great. Thank you. Thank you. So, Roba, Peter is having a question saying in slide 36, is saying the presentation is nice. Sorry, there's some noise. The presentation is nice, but could you please explain to me on the table on slide 36, not understanding why minimum values are greater than maximum values. Please help me understand things. And maybe Gogo, you feel free to address, to give vision. Roba,
Which table?
36, slide 36. Yeah, I think this is
36. Yeah. Okay.
36. Yeah. So the maximum, yeah. So go ahead.
So that normalize actually. Thank you very much for raising such types of questions and in need of clarification. So by acknowledging this one, actually normalized difference moisture index is one of the measure of index that need to identify the soil moisture extent. So the maximum value means the maximum value that while we are classifying with that of the softwares, the maximum values are 0.38 in 1994 as the initial period, whereas in 0.35 is the maximum values in 2024, which means that in 1994 there is high forest, whereas in 2024 the forest areas are decreased. I mean the soil moisture extents are soil moisture variabilities are decreased, which means soil moisture extents are decreased. This is because of the factor because of deforestations. Here is also the mean values are 0.14 and 0.09. The average result of soil moisture or normalized difference moisture index, which showed that the forests in 1994 there is high forest in the area, which showed that there is high values 1.4 as compared to 2024, which is decreased to 0.09, which means that the areas are in the areas, agricultural lands are expanded, while the agricultural lands are expanded without considering environmental changes or sustainable land management. The soil moisture extents are decreased, or the indication of soil moisture values or indices are decreased, and the forests are decreased also. While in 1994 there is high forests as compared to 2024, which may show that decremental trends. That's clear.
Is it clear? But I still put the same question on the. Maybe I didn't get it well. Yes, there's that difference between 1994 and 2004 and 2024, but the values under the maximum column are lower than the minimum column. Is there an explanation towards that?
Which means that the minimum is just the negative values. You have to understand the negative values. The negative values are increased. Negative values mean that there is high deforestation. It showed that.
Great. I think
that is minus. Or okay, consider that the minimum value is negative values. Mean is negative values.
Okay, thank you. Thank you. Gogo, would you love to add something on that? I'd seen you had addressed it.
I think yes, he has addressed the issue. I think he meant to put negative sign on the minimum value so that they appear minimum. But even if you look at the map, yes, it is negative. I think that correction now clarifies. So that's why there was a bit of a confusion.
Thank you. Thank you to all of you. I'll go to, thanks, Peter's acknowledge that. Great. I'll go to the next person. Eldad, I saw your hand. If you can hear me, go ahead.
Yeah, okay. Yeah, thanks for the presentation. It currently falls in line with what we are doing on the field, trying to assess soil features. But this time around, combining GIS tools and then physical assessment and then lab testing. So something struck my mind a bit in the presentation. First of all, in the poster sheet that was shown, I see that some of the conclusions that were drawn is that the research is linking the variation in soil moisture to precipitation, and I want to understand how, unless maybe I missed that point in the presentation, I want to understand how the remote sensing was directly used to make that linkage. And then secondly, I've seen that from the NDMI values, we used 1994, 2004, 2024. Yes, and then I also want to understand what periods within those years were the images taken or used. Thank you.
Thank you, Eldad.
All right. Can I react?
Sure, go ahead.
Yeah, it's very interesting. Thank you very much for the audience for raising such types of very interesting questions. Actually, in this study, we utilized or we considered only GIS-based, where we have not gone for soil or other types of lab test. But this one we recommend for other researchers as they consider it. But we are only rely on just like GIS or technology-based detections. Actually, remote sensing in the GIS is actually the newly emerging technology that can use it to detect, the existence of vegetation covers and others. So, the GIS technology can detect through detections like based on its reflectance, like thermal sensors, based on sensors. We determined the availability of soil moisture availability in the areas based on reflectance. And again, the other question which is raised by why you chose this year specifically, actually these years are chosen with interval in order to see the longer term variation within the interval of 10 years. Actually, specifically in 2004 and around 2004 in our country, there is a resettlement programs actually. The resettlement programs are also in order to see how that resettlement program can affect the areas or the existing forests. But in the 1994, there is high forest. That is, we need to compare these years within 30 years. But in order to say there is a climate change, to the minimum 30 years analysis is very important. So that's why we consider these types of years specifically.
Okay, yeah, a quick one. And on the issue of the years, my concern in particular is with what period within the years, because if we are talking about the impact or the influence of precipitation, the values can be assessed within a short period. Like when we observe a spike in soil moisture over a short period, then you can tell that okay, the spike is as a result of maybe precipitation. If the values have that short span spike. So that is why I'm asking within what period in 1994 was the imagery taken? Within what period in 2004? You linked it with migration program and others. I wanted to know also if it was a period of high rainfalls or a period of dry spells, or that was what I was looking for to hear. Thank you.
Yeah, okay, thank you very much. So actually, as I said before, the year of 2024 is considered to see how the Green Legacy Initiative is effective in the state area, because as a country level, the Green Legacy Initiative is launched in 2001. So to see that one is how much it is effective, we consider 2024. And in 2004, we consider it is how the resettlement program can affect us. In 1994, how the existing forest can be changed. Baseline, that is a baseline for our state in 1994.
Thank you, Rob. And again, I think I saw somewhere in the slide you mentioned that the study was conducted during dry season, to avoid something with cloud and all that. So I think that's
actually, sorry. Yeah, that is technical issues, that is typological errors. But I wanted to say that to take the satellite image, dry season is very important. Actually, to specifically, which means that to reduce the cloud coverage, or like in order to minimize the corrections, like environmental distortion, which is why while we are downloading the satellite image from the DIVA, that I wanted to say like that. That is typological error. Sorry for that.
Okay, thank you. Eldad, I think that's clear now.
Yeah.
Eldad? Okay, just let us know if that's clear for you. Kanyange, go ahead.
Thank you for the actually interesting presentation, and it's so evident that so much work and attention, of details, etc., went into it. So definitely, I can tell you are more of a physical scientist. Myself, I'm a social scientist. So you'll just bear with me if I'll be asking an obvious question. So my question is with regards to satellite data and sensor calibration. So I have noticed that your study spans 3 decades, I think, from 1994, if at all I'm not wrong. You're using Landsat TM, ATM Plus, so I tend to believe these are imagery softwares that you used to get the data for this work. And my question comes in that given the sensor differences and evolving calibration protocols over the 3 decades, I just want to understand, how did you ensure consistency across these data sets? Because I tend to believe that you used the 3 softwares to collect data in each of the decades. Then also just shed light what methodological adjustments did you make to minimize sensor-related uncertainties? Yeah, thank you.
All right. Thank you very much, specifically for raising such a very interesting questions. Actually, the consistency is also kept in way. So that's why I raised in the methodology accuracy assessments to ensure how it is consistently alive within certain decades. We consider the accuracy assessment methods. That accuracy assessment methods are show that how that the 3 decades Landsat images are consistently shows decrement. The other thing is also correction. We have conducted some corrections, like atmospheric correction, geometric correction. This is in the remote sensing language. If it is clear for you, or if you have know-how of this information, such corrections are also conducted, like clipping and other or noise reductions. So through that, the consistencies are kept, and accuracy assessments are also done for the 3 decades for each years of satellite images, using specifically the constant accuracy assessment method like kappa coefficient, and overall accuracy is used to ensure it is consistency, how much that satellite images of the 3 decades are consistently classified. That's we use it accuracy assessment for that one. Yeah.
And Yang, is that
Yeah,
elaborate?
thank you.
Thank you.
Thank you.
And thanks so much, Roba, as well. I can see another question in the chat section. Peter, how did you reduce uncertainty related to surface water relationship to impact soil moisture content you tried to estimate using the NDVI? I can see Gogo has responded to that, but maybe you can add.
Actually, I have also responded at the initial time, but we have not actually conducted the ground recharge potential assessment, but only we see the partial soil moisture variability. We have not conducted like other laboratory analysis, but we compare it with certain types of index, or we alone, or we rely on geospatial technology alone with reflectance related to reflectance. That's why I have already expressed these issues at the beginning.
Okay, thank you. I think we're trying to understand this concept of NDVI and NDMI and DIS and all that, and probably most of us who are not really expert in this field, we've managed to grasp something. So I think time is also much spent. I don't know if there's another question or a comment. Gogo, you're a GIS expert. Do you have anything to say?
So can I say something?
Sure, go ahead.
Yeah, first of all, I wanted to thank the teams of Africa Research and the Impact Network, especially for providing this opportunity to present this study with advanced technologies. I'm also eager to do with that teams, and we have a team to conduct on different researches or research areas. We have more than 1-3 publication with the teams, and we have conducted a number of works even in near future with collaborations. So if anyone have interest to conduct with us specifically for conducting project research and up to publication, I'm just really free, and I'm open to do with everyone. And I wanted to say thank you very much for African Impact Network teams, specifically for arranging these sessions. Really, I understand, a number of things from these sessions, and there is a teamwork, and I have also learned, a number of concepts, extra concepts from the participants. And I wanted to say thank you very much. And if God say also, we wanted to have a team also. We wanted to present in next. We have conducted one study in other side also, the effectiveness of Green Legacy Initiative in some part of our country, even how the Green Legacy Initiative affects the impact of Green Legacy, special assessment of Green Legacy Initiative on climate or temperatures. So if you provide me the opportunity, I also present in the next times. We have conducted a number of research with the teams. So I'm very much happy to present this analysis in front of these teams, really.
Okay, thank you, and you're most welcome. This is a platform that brings together people to peer learn and even share knowledge. And we're really grateful that you found it useful and helpful. We will definitely reach out, and in case of any collaborative opportunity, Irene will definitely reach out to the team. Thank you so much, Robert.
Thank you very much. Thank you very much.
So I requested Gogo if he had a comment on the same. Gogo.
Okay. Maybe can you hear me?
Yes.
Yeah.
Okay. Now, good presentation. I just wanted to add with the current trends on AI and technology, just that's
make it hurry up because my battery is going to low. There is no light currently.
Okay. Sorry for that. I just wanted to say the aspect of AI and technology will help us reduce the aspect of getting the images from 1994 to 2024 and stacking all them in a software that will take time. So the scripting being offered by AI nowadays is making that long process become shorter, and that helps in aiding these processes and even getting the correction, the coefficient, the matrices that you are talking about, the confusion matrix in classification, and that helps in this process. So that's my comment, and I just wanted to add that so that even next time somebody's thinking about that, they can add that to their work to beef up and even to make their work becomes a bit reduce the errors, in short. That is. Thank you.
very much. Thank you.
you.
Really, thank you very much for your positive comment, and we will try to incorporate, and I will even consider it in my next presentation if you allow me.
Sure.
Great. So at this point, kindly allow me welcome Florence to give us the closing remark and close this meeting for today. Florence, over to you.
Lavender, I think this is very useful.
Hello?
Very useful presentation, even as we reflect on what is
Hello?
happening in our country, in the Mau Forest area, and in many other areas where communities are encroaching in the forested land for agriculture or even settlement. And therefore, I think the presentation by Dr. Roba could not have come at a better time. What he has said today is not just a case of Ethiopia. It actually echoes a wider challenge across Africa, how changing land patterns are quietly but significantly altering the continent's water balance. And as much as the example of Ethiopia gives us clear numbers and trends, the underlying message is one that applies across much of the sub-Saharan Africa, as we are seeing forests are shrinking and croplands are even expanding. And this is a ripple effect on soil moisture and even local climates and generally the overall ecosystem health. We have seen in the East Africa, Central Africa, and even in the Sahel region, similar patterns are emerging. Land is being cleared sometimes for subsistence farming, sometimes for commercial agriculture or even settlement, but there is usually very little consideration for the long-term and ecological impact. And because many African economies are still heavily reliant on rain-fed agriculture, this slow erosion of soil moisture is not just an environmental concern, it's an economic concern, it is a food security issue. So the value of today's presentation is not just in its technical findings for me. It has a broader implication, and if we continue to treat land as an infinite resource, we risk pushing entire landscapes past their ecological tipping point. And I think sustainable land management should not just be a buzzword now. It should be something that is very pertinent, something that is key in government policy circles. What I think is clear, maybe to most of us, is that there are community agroforestry activity, landscape restoration projects, and the challenge now is scaling these up, financing them properly, or even embedding them in policy frameworks that just look beyond the short-term goals. And I think these are issues that we should really factor in now. Those practices that we can scale, that can be embedded in policy frameworks just for sustainability purposes. What also stood out for me in this study is that is the power of remote sensing and the GIS tools, just to tell the story in a data-driven visual way. And these technologies are no longer just for scientists. They can and of course should be used by policymakers, planners, and even communities just to monitor land health and of course guide decision making. So I will not say much. As we close this review today, I think we should carry forward a bigger question. And some of these questions are how we can build an Africa that regenerates rather than depletes its natural resources. Because the choices that we make today about land, about forests, about farming will determine whether our soils stay fertile, whether our water will remain available, whether communities will stay resilient in the rapidly changing climate. So as I've always said, these are discussions and ideas that should be scaled beyond such forums. So back to you, Lavenda.
Thank you so much, Florence. We are in the process of developing the Africa we want. That's the Agenda 2063. Thank you so much for those highlights and for giving us that strong closing remark. At this point, I just want to thank everybody who managed to attend this convening, and more so our speaker for just teaching us and educating us on this topic. I'm sure we've learned something. And a hearty gratitude to all of you. And at this point, I'll just request we turn on our cameras to take the final group photo. As Omar, I can see you still sharing some thoughts. Yeah, those are amazing. Thank you so much. So Florence or any other team member, if you can just assist us in taking the final group photo, I'll appreciate. Just let us know when you're ready so that you can smile.
You're already
Everyone is
smiling.
Smile.
Yeah.
So you're done.
Thank you so
Nice weekend.
Thank you, Flo. Thank you, team. Thank you, Roba. And thank you, Gogo. Thanks, everyone. May you have a fantastic weekend ahead. And yeah, see you in the next phase of life. Bye-bye.
Thank you. Bye-bye.